Hello everyone and welcome once again to my channel. This time we are going to be having questions in the world of chemistry for those that are preparing to write in the Jamb 2025 examination. Now these questions will be of help to you, so do well to stay glued to this channel as I run through the series of most important questions that Jamb often repeats. And these are questions that they usually bring out in their previous years. So you have to be very attentive and stay glued to it as I start. Now, looking at question 1, which of the following is not a soluble triisocarbonate 4? Which of the following is not a soluble triisocarbonate 4? Meaning, in this kind of question, among the 4 options, you are having 3 of them to be soluble, while only 1 is insoluble. And that one that is insoluble is actually the answer to the question. Now, there is something you need to take note of. When I say triisocarbonate 4, triisocarbonate 4, they are simply compounds that ends with what? CO3. Those are the triisocarbonates. And among the triisocarbonates, the only salts or the only compounds of the triisocarbonates that are soluble are 3. And what are they? We have sodium carbonate, we have potassium carbonate, and we have ammonium carbonate. So these are the only triisocarbonates that are soluble. The other triisocarbonates are insoluble. So the correct answer to this question is option D. So please take note of this. And again, they might bring a question on which of the triisocarbonates are stable to heat. When I say stable to heat, I'm referring to those compounds that when heated, they do not get decomposed. And among the triisocarbonates, there are also 3 that are stable. And what are they? We have the sodium carbonate, we have the potassium carbonate, as well as the barium carbonate. So these are the 3 that are stable to heat, meaning that when you apply heat on them, they do not get decomposed, while the others, they decompose upon heat application. So you should also take note of that. Then the next question, so number 2. Looking at number 2, we are given a reaction, and that reaction is a reaction between nitrogen and hydrogen to form ammonia, which is given in this. And then you are having the equilibrium constant for the reaction shown above is, now there is something you need to take note of about equilibrium constant, KEQ. Now it is given as the concentration of the product raised to the power of the coefficient, then over the concentration of the reactants also raised to the power of the coefficient. All right. So what does that mean? It means that when you are given an expression like this, you have to write the product. The product should be above, then while the reactant should be written beneath. But then again, there is something else that you need to take note of. It is only gaseous molecules or gaseous particles as well as aqueous solutions that can appear in equilibrium constant. For pure solids and pure liquids, they do not appear in equilibrium constant. So it simply means their concentrations is considered constant. So that's the reason why they don't appear. What I'm trying to say in effect is this, that this is gas, gas, and gas. So the 3 of them will appear. Assuming we were having, let's say, one of them to be liquids or one of them to be solids, it means that they would not appear. So looking at this, we should write our KEQ, very easy, and then we are given the product now, which is this guy. So that becomes what? NH3, then the concentration raised to the power of what? The coefficient, which is 2. So that's that. Then over, we are now having what? N2, concentration of N2. This square bracket means concentration. Then there is no number here, so you just leave that like that. Then the next, multiplied by concentration of what? H2. What's the coefficient of H2? 3. So raised to the power of 3. So that's how you get it. Is that easy? So any number you're having before the substance, you have to write it as a power. You get? That was what I did here for hydrogen. The coefficient here was written as the power. Then same with this. The coefficient here was written as the power. So it must be product, which is the one at the right, over the reactant. And mind you, like I said, when you have anything like liquid or solid, they do not appear. All right? So take note of that. Okay, let me just give you an illustration of, let's say, a given question. CaCO3, then of course you have the metallic oxide and CO2. So looking at this, if you are told that you should represent this in equilibrium constant, how would you go about it? It's very easy. Now, this one is now seen to be the product. Of course, this is solid, and this is gas. So in this case, remember I said that the product over the reactant, that should be KEQ is equal to, now, solid will not appear. These two solids are out. So we are left with what? This guy, which is CO2. Then we don't have anything there, so you just write it like that. So that's how you go about it. So you don't actually make solids to appear in equilibrium constant. So it's that easy. Then the next question, question 3. So what did I get as my answer to that number 2? I think I obtained this guy, which is C, because I actually wrote this and I raised it to the power of 2, and then I wrote this 2, and then I raised the hydrogen concentration to the power of 3. So that's the answer to the question. Then number 3, the reaction which takes place at the cathode of an electrolytic cell is dash. Of course, I've given a code one time that for you to know the reaction that occurs at the cathode or at the anode during electrolysis is by the use of this code, crowd. That C is to arrow, then A is to O, meaning cathode is to what? Reduction, and anode is to what? Oxidation. So they said the reaction which takes place at the cathode of an electrolytic cell is, of course, it is what? Reduction. So the correct option is option B. The next question, number 4. The gas evolved when sodium metal reacts with ethanoic acid is, now what's ethanoic acid? Ethanoic acid, the formula is CH3COOH, then plus, then we have sodium metal, which is Na. So when we carry out this reaction, we have to obtain CH3COONe, then plus what? H2. So when we balance the reaction, we should be having 2, and then we should be having 2 and 2. So this reaction is balanced. What do you notice? Now we are having sodium ethanoate as a product, which is the salt, and then the gas liberated is hydrogen gas. So there's still a code that you can use for this. Instead of even representing this reaction to confirm it, you can as well use this code that under acids and bases, whenever acids react with metals, they tend to liberate what? Hydrogen gas. That's one of the chemical reactions of acids. So the correct answer is B, hydrogen gas. Then number 5. Which of the following is the functional group of the alkanols? Now they are taking us to organic chemistry. Now alkanols, they are under organic chemistry too. And there was a video lesson I made in this channel, and then where I said that alkanols, they are known by their general formula ROOH, and they are known by their functional group OH. Simply means that ROOH is general formula, then OH is what? Functional group. So the functional group of alkanols is OH. This is the functional group of the alkanals. Then while COOH is the functional group of the alkanoic acids. Then triple bonds is the functional group of the alkynes. So take note of that. So let's look at the next question. Question 6. A compound of aluminium called alum is used during water purification for, now we have different steps of water treatment or water purification process. And what are some of these steps? The first is coagulation, which involves the addition of alum. And then the second is sedimentation, which involves subjection of the water into a settling tank in order to allow the fine particles or debris to settle properly at the bottom of the tank. Then after sedimentation, we have filtration, separating the clear water from the debris. And then we now have chlorination, which is addition of chlorine in order to kill germs. Then fluorination, addition of fluorine to prevent tooth decay. Then iodination, addition of iodine to prevent goiter. And then addition of calcium hydroxide, which is liming process, in order to adjust the pH as well as to improve the taste of water. So a compound of aluminium called alum, it has even been named here, is used during water purification for what? For coagulation. So the answer is coagulation. All right. And that coagulation is also called flocculation. All right. So take note of that. And the commonly used alum that is used is called potash alum. Now, potash alum has a formula KAlSO42.12H2O. IUPAC name of this is potassium aluminate 3 tetraoxosulfate 6 dodecahydrate. So that's the IUPAC name of that compound. So the next question, question 7. Which of the following is not a covalent molecule? A N2, B NaCl, C NH3, D CH4. How do you know covalent molecules? It's very easy. Now, when you have non-metals coexisting together, that's actually covalent. So in this case, nitrogen happens to be a non-metal, and we're having 2 atoms of nitrogen. That should tell you that indeed this is covalent. So non-metals coexisting together, covalent. So this is wrong. Then ammonia, nitrogen, hydrogen, covalent, wrong. Then carbon, hydrogen, covalent, wrong, because these are non-metals. But this one is a metal and a non-metal. So this is electrovalent or ionic. So this becomes the answer. All right. Then number 8, the enzyme maltase converts maltose to molecules of. This question is a very cheap one. Now, you know that maltose is a disaccharide, and maltose, when it is broken down, it releases what? Glucose units, about 2 units of glucose. So there's a code GGM, GGL, GFS. What does this mean? Glucose plus glucose gives a maltose unit. Glucose plus galactose gives a lactose unit. Then glucose plus fructose gives a sucrose unit. So these ones are called disaccharides, while these ones they are what? Monosaccharides. So even from the substrate, you can tell the enzyme that can act on it. So the enzyme that acts on this, that breaks it down to releasing glucose units, is called maltase. So it's glucose that is obtained in the process. So the correct answer is option D. The next question. How many ions are produced when a double salt dissociates in water? How many ions are produced when a double salt? Now, look at this salt that I wrote, that potash alum. Now, potash alum is an example of a double salt from that previous question. So this every double salt contains two cations and one anion. Remember that the cations, they are positively charged, while this one is what? Negatively charged. So if you combine 1 plus 2 will give a total of how many? 3 ions. Even judging from this compound here, which is the potash alum, if I dissociate this, is K plus, Al3 plus, and what? SO4 2 minus. So how many ions are here in total? There are 3 ions. So the correct answer is option C. Next question, question 10. NH4Cl dissociating to producing NH3 ammonia gas and hydrogen chloride gas. So they are asking, this question is coming under chemical equilibrium. Now, if you check this my channel, then you ought to know that there was a time I did a video lesson on chemical equilibrium. You can watch the video to assist you. But looking at this question, they said our delta H is given, which is enthalpy change, is given to be positive 86 kilojoules, and then the forward reaction is favored by dash. So one thing that you need to know about chemical equilibrium is that if you are having A plus B to give C plus D, in this case, we are having two-sided reactions, forward and what? And backward. If you are giving your delta H value to be positive, it means that the forward reaction here is endothermic. Then while the backward is exothermic. Why? Because it is having a delta H value of positive. But when your delta H value is negative, then the forward reaction will be what? Exo. Then while the backward reaction will be what? Endo. You get the point now. And one thing that you need to know is this, that endothermic reactions, they involve the gain or the absorption of heat, meaning that what will favor endothermic reaction is what? Increase in temperature. Why? Because endothermic loves heat. So when you raise temperature, you are applying heat in the process. So it means that an increase in temperature favors endothermic, while for exothermic, a decrease in temperature favors exothermic. So it's very easy. If your forward reaction is exo, what would favor the forward reaction there? Of course, it is decrease in temperature because that's what favors exothermic. But if it is backward reaction, you are asked to get what should favor it. Backward reaction in this case is endothermic. So if it's endothermic, what should favor it? Increase in temperature. All right. So looking at this question, we are giving our delta H value. So it means that there is a consideration that should be placed under temperature. Yes. Why? Because you are giving a delta H value to be positive. That's still a code. But then the other options would not, if you confirm. Increase in pressure would not, because an increase in pressure favors the part of the reaction with the smaller gaseous volume. All right. And looking at this, the forward reaction was what we were asked. Going like this is gas, while this is what? Solid. So it's obvious that these two, they are like, the volume here is 1 and the volume here is 1. So total volume here is what? 2 volumes. But over here, you don't even have any, so it's 0. So it means an increase in pressure is supposed to favor the backward, but we don't have any gaseous volume there because this is with the higher gaseous volume. But then now they are asking us which one will favor the forward. So it means increase in pressure is out. Then removing the reactant. What's the reactant here? This guy. And one thing about effects of change in reactants is this, that when you remove reactant from a particular side of a reaction, it favors that same side of the reaction. What does that mean? Let's just assume that we are removing from A and B. It should favor the backward reaction. If we are increasing A and B, it should favor the forward reaction. I would want you guys to watch that video lesson I made on chemical equilibrium. So looking at considering this guy now, based on we were given delta H, so it means this should be ascribed to temperature. So you should focus on temperature in the options. So delta H is positive. From what I've explained, if delta H is positive, what does that mean? It means the forward reaction is what? Endothermic. Then why the backward automatically will not be what? Exothermic. And what did they ask us? The forward reaction is favored by. Now, what did I tell you guys? Shall I say that for endothermic reaction, the forward reaction, what should favor it in terms of temperature? An increase. Because when you increase temperature, you favor endothermic. Then the backwards reaction will be favored by what? A decrease in temperature because it's exothermic. So the correct option is what? Is increasing temperature. So that's the right answer. Then let's see the next question. Question 11. A metallic ion Z2 plus with an inert gas structure contains 18 electrons. How many protons are contained in this ion? Now the thing is this. This was what we were given. Zn or Z2 plus. Now we are given Z2 plus and we are told that it contains how many electrons? 18 electrons. So it's from this that you have your 18 electrons. Now we are told how many protons are contained in this ion. Now normally this guy 2 plus simply means that there is a loss of 2 electrons, meaning that electrons have been lost here, which is 2. So previously you were supposed to be having how many electrons? 20 electrons, assuming we did not lose any electrons. So when an atom is in a neutral state, the proton and the electrons, they are the same. So it means without these 2 plus, you are going to be having 20 electrons. And without that 2 plus, it simply means you'll be having Z as Z. And of course, that will be a neutral form of Z. And when Z is neutral, it means the electron number is the same as the proton number. So hence, the proton number will be 20. So the answer is option A. The next question. The valence electrons of magnesium, which is, they even gave the atomic number of magnesium here, are in the dash orbital. The valence electrons of magnesium are in the dash orbitals. Now, the first thing we need to know is that what is valence electrons? Now, valence electrons simply means what? Outermost shell electrons. That's what valence electrons mean. Outermost shell electrons. And how can we get the outermost shell electrons of magnesium? Now the Mg is given as 12, which is the atomic number of Mg is 12. So since this guy is not carrying a charge, then the electron will also be what? 12. So K share will take 2 electrons, the next will take what? 8, then which is total of 10. Now we are left with 2. So this is the innermost shell, while this is the outermost shell. So how many electrons are there? 2. So it means these last electrons, what orbitals would you find the last 2 electrons? So let's check. Now you need to know what is called energy gradation. Talking about energy gradation, you should be having 1s, 2s, 2p. This shouldn't be new. Then 3s, 3p, and 3d. Then you can just take the slantness of the lines like this. That should give us what? That should give us 1s, 1s, then 2s, next 2p, then next 3s. I think we have to stop here because of the total number of electrons we want to fill. Remember that this Mg12 has a total of 12 electrons. So it means our 1s will take 2. So 1s2. Our 2s will also take 2. 2s2. Then our 2p will take what? 6. 2p6. And the last one, 3s, will take what? 2. 3s2. If you sum up these numbers now, it gives what? 12. So these last 2 electrons, which are the valence electrons, what orbital can you find them? In the 3s orbital. So the correct option is option A. Alright, so just do well to understand this orbital representation. You know that S can take maximum of 2. That's the reason why I wrote 2 there. Then YP takes maximum of 6. Then D is 10. F is 14. So the correct option there is option A. The next question. Nitrogen is located in a dash of the periodic table. This question is a very cheap one. Now, firstly, we must know what nitrogen, the position you can find it. When you are reciting your first 20 elements, what position can you find nitrogen? The 7th position. It means that nitrogen has how many electrons? 7 electrons. So going by shell configuration, or you want to represent it electronically, then your K share will take what? 2. Then while the next will take what? Will take 5. Alright, this is 2, 5. So in this case, now we are told nitrogen is located in dash of the periodic table. They are interested in what period and what group can you find nitrogen. With this, you can get it. This is like a shortcut to it. Because no need of you drawing periodic table. You don't have enough time to be doing that in your Jamb hall. All you simply do is, since they are asking you for group and period, now normally, elements in the same group, they have something in common. And what's that? They have the same valence electrons. I've explained what valence electrons are. Outermost shell electrons, meaning group 1 elements, all of them will be having 1 as their valence electrons. Then group 2 elements will be having what? 2. That's how it works. Group 3, 3. Group 4, 4. Group 5, 5. You get? So in this case, since this guy, share these are the valence electrons because they are found in the outermost shell. So the valence electrons here is what? 5. Since it has a valence electron of 5, then it must be found in what? In group 5. Is that easy? So now we know the group. Then next, what is the period can you find what's it called? Nitrogen. It's very easy. Just count the total number of shells. Periods can be obtained by the number of shells. So in this case, how many shells are here? 1, 2. So since we have 2 shells, which are K and L shells, that's 2 in total, then this element is found in period 2. So in a nutshell, I can say that periods of elements are determined by counting the total number of shells, while the group of elements are determined by counting the total what? Valence electrons. Is that easy? So it means nitrogen is found in group 5 and period 2. Group 5, period 2. Option B is right. Then the next question, number 14. What would be the value of X to balance the chemical reaction? This is on balancing of reaction. This thing is very easy. This is the chemical reaction we are giving. And then they are asking for the value of X. All you simply just do, let's confirm something. Now, shall we are having chlorine here, but over here, chlorine is what? 2. If I make here 2, it becomes 2 what? Chlorine, because this 2 will affect everything. That's how you balance reactions. So it becomes 2 chlorine. Then now, what about our sodium here? Say sodium has also been affected. So it's this 2 sodium. So for we to make sodium 2 here, we have to write 2 here. And then, of course, then if you check, NO3 here is affected by what? 2. Then this 2 is also affecting the NO3 here. So it means everything becomes balanced. And as a matter of fact, since you're having x appearing in both sides, the x must be of the same value because all your options, you're having single values there. So it means the correct option is option C. That's the balanced reaction. Then question 15. Given that the relative molecular mass of a gas is 64, determine the vapor density. Now, what's the relationship? Please, you must remember this. The relationship between molecular mass and vapor density or density is given as molecular mass is equal to 2 times density. All right? 2 times density or vapor density, whichever one. So it means that for you to get the molecular mass, you have to multiply the density of the gas by 2. What about if you want to get the density? You have to divide the molecular mass by 2. Meaning, if I want to get density now, it should be what? It should be molecular mass over 2. So that's how it works. So given the relative molecular mass, now we are given the relative molecular mass to be 64. And then we are told to determine the vapor density. So all you simply do, just divide this 64 by 2. And then that gives what? 32. So the correct option is option D. Then let's see the next question. Question 16. Which of these is yellow in a basic medium? Now, A, indicator, B, phenolphthalein, C, litmus paper, and D, methyl orange. Now, this question is a very easy one because indicator is out. The reason is because we have different indicators. So they are interested in the particular indicator that is yellow in a basic medium. Now, phenolphthalein, litmus paper, and methyl orange, they are common indicators. Then which one of them is yellow in a basic medium? Now, there is something you need to take note of. We have two media in terms of different colors of indicators. We have acidic and we have basic. Then I think there is one that is considered as neutral. But the two main are acidic and what? And basic. Now, looking at these indicators, talking about phenolphthalein. For phenolphthalein, what I want you guys to take note of is just in case they bring questions with regards to the others. Phenolphthalein in an acidic medium is colorless. Colorless. Then in a neutral medium is also what? Colorless. Then in a basic medium is pinkish. So it's pink. Then that of the next, which is methyl orange. Methyl orange in an acidic solution is red. In a basic solution is yellow. Then in a neutral solution is orange. Then litmus paper, litmus in an acidic solution is red. Then in a basic solution is blue. Then in a neutral solution is purple, or you can go with magenta. So please take note of that. So what should be the answer now? Which amongst the three of them in the options is yellow in basic medium? Is methyl orange. So the correct option is option D. So please take note of this, it's very important. The next question, question 17. What is the color change observed when ethyne is passed into an ammoniacal solution of copper 1 chloride? This one is based on tests to distinguish the alkynes from the alkenes. All right, and it's only determining alkynes that react with such reagent. Then, looking at it, they said what color change will be observed when ethyne is passed through a solution of ammoniacal copper 1 chloride. Now, this solution is actually having a bluish color, so it's bluish. Then, when you pass it through ethyne gas, then it tends to convert the color, change the color from blue to reddish brown. Reddish brown. All right. So that's what it converts it. And the reddish brown is actually called copper dicarbide. So the copper dicarbide that will be formed is reddish brown. So the correct option is blue to reddish brown, which is option A. Then let's say another, a solution of ammoniacal silver 1 nitrate. This guy here is colorless. So when you pass this guy through ethyne gas, then ethyne gas will convert it to what? To pale yellow or whitish yellow, whichever one. So from colorless to whitish yellow, that's a solution of ammoniacal silver 1 nitrate, in case they bring questions on that. So take note of that also. Then the next question, question 18. Which of the following pairs of compounds are geometric isomers? There was a time I treated isomerism in this channel. You can check for it. Isomerism. Now, when we talk about geometric isomerism, what should come to your mind? Another name for geometric isomerism is cis-trans. Cis-trans isomerism. Alright, that's another name for geometric isomerism. Then what does this entail? What's it all about? Now, for a compound to exhibit cis-trans isomerism, firstly, that compound must possess double bonds. That's one. Then secondly, the carbon atoms that are connected by the double bonds must contain the same group. What does that mean? It's just like you having something like this. And then you have A here and you have B. And over here you have A and you also have B. What do you observe? This kind of compound can exhibit what? Cis-trans isomerism. Why? It has double bond, which is the first criterion. Then the second is that the two carbons linked by the double bonds must contain the same group, AB, AB. So in this case, you can call this the cis configuration. Why is it called cis configuration? Because in this kind of isomerism now, we are having the cis configuration and we are having the trans configuration. What does it mean when we say cis configuration? It means when you cut it, this is just like a code. When you cut it from the midpoint like this, then the upper layer or the upper axis, if you're having the same group there, is cis. But if you're having different groups, is what? Is trans. That's what it means, just like a code. So what about if I had removed this guy and I put B here and then I put A here? In this case, these two now, they are what? Different groups on the same axis. So hence, this is called what? Trans. All right. So let me give you an illustration using a compound. Let's say we are having something like this. We are having this. Now, this compound can exhibit cis-trans. The reason is because firstly, it has double bonds. These two carbons now, they are containing the same group. So would you call this one cis or you call it trans? Check. Upper axis. Do you have the same group here? Yes. That's what? Cis. So if you are naming this compound, this is our longest carbon chain. And how many carbons are there? 1, 2, 3, 4. And if you are numbering 1, 2, 3, 4. 1, 2, 3, 4. That's for backward. It's still the same thing. Going by forward, where can you find your double bonds? Between 2 and 3. How many carbons are there? 4. That's what? Boot. Then between 2 and 3, which one is smaller? Is 2. That's boot. 2 what? In. So what would you call this? Would you call it cis or you call it trans? This should be what? Cis. Why? They are in the same axis, the same group are on the same axis. So this is called cis. Assuming I had removed this guy here and placed the hydrogen here, and then I placed the CH3 here, then you should have changed it to just what? Trans. Only this thing should be changed. Then why the other thing still remains the same? So the one that is exhibiting the geometric isomerism is cis but2 in and trans but2 in. So anyway, you just see cis and trans, just know it has to do with geometric. So the correct option is what? B. This guy here is actually what's it called? Positional isomerism under the structural isomerism. So watch that video, you will learn a lot. Then we have butane and 2-methylpropane. That's this is also structural isomerism under the chain isomerism. Then while this one is butene and cyclopropane, that's under the structural isomerism, then functional group isomerism. All right. So the correct option is option B. Question 19. Question 19. What is the type of hybridization that exists in a molecule of ethyne? The type of hybridization that exists in a molecule of ethyne. Ethyne is a member of what? Of the alkynes. And if you have watched my introduction to the world of organic chemistry in this channel, I told you guys that alkynes are sp hybridized, alkenes are sp2, then alkanes are sp3. So the correct option is what? Sp. Very easy, because ethyne is a member of alkynes. Then the next question. Which of the following compounds is a neutral oxide? Neutral oxides. When I say neutral oxides, I'm referring to oxides that neither possess what? Acidic nor basic properties. They don't have any of the properties, hence they are neutral. And what are classical examples of neutral oxides? We have CO, we have N2O, we also have water, H2O. This guy is carbon 2 oxide. This is dinitrogen 1 oxide, also called nitrous compound, which is also known as laughing gas. And then this guy is water. So these three are classical examples of neutral oxides. Most times they are asking questions on this in Jamb. They prefer bringing any of these three. So let's check the options. Sulfur 4 oxide is there, which is wrong. Carbon 2 oxide is correct. That's B. The others, carbon 4 oxide, sulfur 6 oxide, that's sulfur 4 oxide SO2, carbon 4 oxide CO2, sulfur 6 oxide SO3. These three, they are examples of acid oxides, or you can call them acid anhydrides. All right. So when you read up oxides, you tend to know that we have 5 types. We have the acid oxide, the basic oxide, the neutral oxide, the amphoteric oxides, and we have the peroxides. So let's quickly look at the next question. Question 21. The minimum amount of energy required for a reaction to take place is dash. These are the options. Option A, activation energy, B, kinetic energy, C, lattice energy, and D, ionization energy. Now, the correct option to this question, without even thinking, is activation energy, because they said the minimum amount of energy that is required for a chemical reaction to occur. So, activation energy is simply the minimum amount of energy that is required for reactant particles to possess in order for them to collide for a chemical reaction to occur. Now, it can never be kinetic, but that one talks about energy that is in motion. Then, while that of lattice is the energy that is required to split or to separate a mole of ionic compounds that are existing. That is the element. Then for D, ionization energy is simply the energy that is required to remove or to pull off electrons from a neutral gaseous atom that is isolated. So option A is the right answer. Then number 22, an insoluble salt can be prepared by dash. A, the action of dilute acids on insoluble base. B, the reaction of metals with an acid. C, the reaction of carbonates 4 with an acid. And D, double decomposition. Now, this question is particularly to those students that love to guess, and they often select their right answer by looking at the option containing the longest number of words. Please, I would beg you, this is not so in this kind of question. Because now this question is very easy. Why I had to select this question is because I have seen this question repeated oftentimes in your JAMB pass question. Now, looking at this question, insoluble salts, they are best prepared by a method known as double decomposition. And when I say double decomposition, it doesn't mean decomposition reaction occurring twice. No. What it means is that you are having two soluble salts exchanging their ionic radicals to forming an insoluble salt and a soluble salt. So it's just like soluble, soluble to form insoluble and soluble. Now let's check. If you have a soluble salt, let's say silver nitrate, this is a soluble salt. If you want to understand solubility rules of salt, you can watch my video lesson on this channel. I posted on this channel with regards to solubility of salt. So if you want to know those salts that are soluble and those that are insoluble, you can watch that video. Now, silver nitrate reacting with sodium chloride. These two salts, they are soluble. So when they react, that's double decomposition for you. These two will exchange their ionic radicals, meaning that if you dissociate this, you are going to obtain what? Ag plus and what? NO3 minus. Why this one should give us what? Na plus and Cl minus. So unlike charges will do what? Attract. This will attract this to form AgCl, and then this would attract this to form NaNO3. That's nano 3. So in this case, this guy is insoluble salt, while this is what? Soluble. So this is a good example of double decomposition, where you are having soluble soluble to give what? Insoluble and soluble. So that's the method that can be used, best used to preparing insoluble salt. Then question 23. In question 23, we are having 10 dm cube of water added to 2.0 mole per dm cube of 2.5 dm cube solution of HCl. What is the concentration of the final solution in mole per dm cube? This question is still a very easy question because it is coming from dilution law. And dilution law says that we are having C1V1 equal to what? C2V2. Let's bring out the parameters. 10 dm cube of water. Listen attentively. Whenever you are given questions like this on dilution law and there is the mention of water, you have to be extremely careful. I know what I'm saying. Now, let's just check something. 10 dm cube of water added to 2.0 mole per dm cube of 2.5 dm cube solution of ACl. So 2.0 mole per dm cube is our initial concentration, which is C1, 2.0 mole per dm cube. All right. Then what was our initial volume of the solution? This guy. So our initial volume was 2.5 dm cube of that acid. Then now, what's our other concentration? That's what we are told to find, the final concentration, which is C2. So C2 is unknown. That's what we are told to find. Then what's now our V2? Remember that 10 dm cube was added to this guy. So for we to obtain our V2, we have to add this guy to this in order to obtain our final volume, which is our V2. So that should be what? 10 plus 2.5. That should give us what? 12.5 dm cube. So our volume here is 12.5 dm cube. So let's run to this now. For we to get our C2, it becomes C2 equal to what? C1 V1 over V2. So that should give us C2 equal to what now? What's our C1? 2 times, what's our V1? 2.5. Then what's our V2? Our V2 is what? 12.5. So with the help of our calculator, we can easily obtain our answer. So let's work with our calculator in getting our answer. So working with our calculator to getting our answer now, we should be having 2.5 times 2, then divided by 12.5. That should give us 0.4. So our answer is C, which is 0.4 moles per dm cube. All right, so that's our answer. Then let's look at the next question quickly. Question 24. Question 24, we are given that steam changes the color of anhydrous cobalt 2 chloride from, now this is paper test for water, paper test for water. And when we say paper test for water, there are two papers that can be used to test for the presence of water. And what are the two papers? We have anhydrous copper sulfate paper, and we have anhydrous cobalt chloride paper. This guy, the color changes from white to blue. Then while this guy changes from blue to pink. So what did they ask? Anhydrous cobalt 2 chloride, which is this guy. So it changes from what? Blue to pink. So the correct option is option A. The next question, number 25. Which of the following molecules are held together by hydrogen bond? Hydrogen bond. Now, one thing that you need to know is this. Hydrogen bond is an example of intermolecular bond, meaning bonds that exist between molecules. So looking at hydrogen bond, how is it formed? It is formed when hydrogen is covalently bonded to highly electronegative elements. And what are these peculiar elements? We have FON, that's what I use as a code, FON, meaning fluorine, oxygen, and nitrogen. So when hydrogen is bonded to any of these elements, then there is hydrogen bond. For example, HF possesses hydrogen bond, which is hydrogen fluorine. Then what about H2O? It possesses what? Hydrogen bond, hydrogen oxygen. Then NH3 also possesses hydrogen bond, nitrogen, hydrogen. So the correct option is option B in this case. All right. So let's see the next question. Question 26. How many unpaired electrons are there in the p orbitals of a fluorine atom? Now, fluorine is F. It has how many electrons? 9 electrons. Why? Because fluorine, when you are reciting your first 20 elements, fluorine is found in the position 9. Now, how can we obtain the number of unpaired electrons? Unpaired electrons in p orbitals. Remember our code now, 1s, 2s, 2p. Now, I think it should end here because now 1s will take 2, then 2s will take 2. Then now, how many should we add to this to get 9? It should be what? 2p5. Now, if it's 2p5, remember that p is a degenerate orbital, meaning it can be split into 3 parts. So if this is 2p and it contains 5 electrons, we are to obey Ohm's rule. Ohm's rule says that when you are filling degenerate orbitals, you have to fill singly before you start pairing. So since we want to put 5 here, it becomes 1, 2, 3, 4, 5. So in this case, in the p orbital, how many electrons are unpaired? It's just this guy. So it's just 1. All right. So the correct option is option A, 1. Then question 27. This question 27, I think I did a video on radioactivity, how to calculate decays, number of decays. So in this case, we are giving 20 grams of a radioactive substance decays to 10 grams in 5 seconds. So it's obvious that the half-life is what? Is 5 seconds, because if you half 20, you get 10. So since it takes 5 seconds, that should be the half-life. So what mass of the substance remains after 20 seconds? Remember our code. We are starting with 20 grams. So 20 grams over 2 will take what? 5 seconds for it to decay into 10 grams. So this same 10 grams over 2 will take another 5 seconds again to decay to 5 grams. So 5 grams over 2 will take another 5 seconds. You know that what I'm doing here is that I want to get a total of how many seconds? 20. So it will take another 5 seconds to decay to 2.5 grams. Now 2.5 grams will take another 5 seconds to decay to 1.25 grams. So in this case, if you sum up 5 plus 5 plus 5 plus 5 is what? 20 seconds. So what was the question? He said, what will be the mass of the substance that will remain after 20 seconds? So after 20 seconds, what you are going to be left with is 1.25 grams, which is option D. So question 28. Which of the following types of reactions is not a characteristic of alkenes? So now, if you've watched my video, the first video I made on introduction to the world of organic chemistry, under the alkenes, I said chemical reactions of the alkenes includes the chemical reactions of alkenes includes, we have combustion reaction as one, then we have addition reactions as well as polymerization reactions. So which of them is not? Let's check. Combustion is, addition is part of it, polymerization is part, then this is not. This is a typical reaction that is peculiar to alkanes. So the answer is substitution. Question 29. A molecule of oxygen gas has a dash shape. When we say a molecule of oxygen gas, we are referring to O2. And remember that all diatomic molecules, what I meant by diatomic molecules are simply molecules that have their atomicity to be 2. So like O2, H2, N2, Cl2, CO2, they are all linear shaped molecules, meaning they are straight, linear shaped molecules. And as a matter of fact, all linear shaped molecules, from the word linear, which is straight, angle on a straight line mass is measured at what? 180. So all of them here will be having a bond angle of 180 degrees. So hence, oxygen molecule is actually what? Linear shaped, which is option A. Then number 30, a solution that resists changes in pH on adding small amounts of acids or alkalis is called a or an is known as a buffer solution. Now, buffer solutions, they are simply solutions that resist slight changes to what? To pH. And of course, how do they resist changes to pH when small amounts of acids or bases are added to it? Of course, it's due to the fact that buffer solutions, they are made up of what? They are made up of weak acids or bases and mixed with what? Their corresponding conjugate base and acid respectively. What does that mean? In a nutshell, I can say that buffer solutions, they are made up of what? A mixture of weak weak acids or bases and their conjugate conjugate base and acids respectively. So what does that mean? It means that when you bring a weak acid and you mix it with its conjugate base, then of course that gives you a buffer solution. Or you bring a weak base and mix it up with its conjugate acid, it gives you what? A buffer solution. All these conjugate acid, conjugate bases that I'm making reference to, what do they mean? For example, this is a weak acid, CH3COOH. Now, if I dissociate this, partial dissociation, of course, double lines, it should give me CH3 COO minus and what? H plus, meaning it has donated what? A proton. So it means this is what? Is conjugate base. So conjugate bases, they are simply substances that are remaining after an acid has donated a proton. A proton. Emphasis on that a proton. So proton is in the form of H plus. So when proton is removed from an acid, then what is left of that acid is called its conjugate base. And of course, this acid is a weak acid. As a matter of fact, all organic acids are weak acids. So this is its conjugate base. So this weak acid and its conjugate base, a mixture of these two will give the formation of a buffer solution. All right. Then you can as well still say that a mixture of a weak acid and its salt can also function in the area of forming buffer solution. How? I can mix this guy with CH3 COONE and it gives me what? A buffer solution. So we have acidic buffers and we have basic buffers. It all depends on what you are using to form the buffer solution. So let's see the next question. Question 31. Which of the following chemicals will dissociate completely when added to enough quantity of water? Now, this question is taking our minds to acids, because if you check all the acids, all the options rather, they are all acids. And we have strong acids and weak acids. Strong acids are simply acids that dissociate or ionize completely in solutions, that's in water. Then while weak acids, they dissociate partially in water. So let's identify the strong acid. That will be our answer. Ethanoic acid is a weak acid, so this is wrong. Triazocarbonate 4 acid is a weak acid, wrong. Then triazophosphate 5 acid is wrong. That's a weak acid. Then hydrochloric acid is right, which is a strong acid. So that's the correct answer. Then next, 32. The collision of reactant particles which results in a chemical reaction is known as dash. Now, you know, for a chemical reaction to occur, there must be collision between reactant particles. And this collision, it is not all of them that result in chemical reactions. Now, some reactant particles can collide without carrying out any form of chemical reaction or without resulting in chemical reactions. So, it is not all collisions that result, only effective collisions that result in chemical reactions, meaning that the collisions that align and not only that, that have enough energy, not enough activation energy to proceed with a chemical reaction. So the correct option there is option A. Only effective collision can result in chemical reactions. Then question 33. Which of the following elements is not a S-block element? Which of the following elements is not a S-block element? Option A is magnesium, B potassium, C hydrogen, and D chlorine. Now when we talk about blocks of elements, we are having the S block, we are having the P block, we are having the D block that's coming from the SPDF, and then we are having the F block. Now, S block elements, they are simply elements whose orbital configurations ends in the S orbital. So what are the group of elements that are S block? We have group 1 and group 2. Group 1 and 2 elements, they are S block. Then P block elements are from group 3 to group 8. 3 to 8, they are P block elements. Then D block elements are transition elements. Transition elements. And you must know your transition element from 21st to 30th elements. They are classical examples of transition elements. Talking about scandium all through to zinc. Then the F block elements, they are known as the lactanites, the lactanites and the actinites, the lactanites and actinide series. When I say lactanites, I'm referring to the period that starts with lactanum and ends with lutetium. Lutetium. Now, lactanum is actually having its atomic number of 57, and then while lutetium is 71. Then for that of the actinide series, the element starts with actinium, 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 and ends in lawrencium, lawrencium. Now, this has an atomic number of 89, while this is 103. So, these lactanite and actinide series, they are F block elements. So, for the group 1 and group 2 elements, they are S block. Then P block is from group 3 to 8. So, which ones are from the question now? They said which of the following elements is not S block, meaning the one that is not a group 1 or group 2 element. This is group 2, group 1, and this is not. So, this is a P block element. That's for chlorine. So the answer is chlorine in this case. So question 34. The next question. Question 34. We are having a chemical reaction where heat content of product is less than that of the reactant is called dash. If you watch my video lesson on enthalpy, entropy, and Gibbs energy, this question will just be very easy for you. Now, when you have your heat content of product to be greater than heat content of reactant, the reaction is what? Is endothermic. Just take note of this. But when you have your heat content of product to be less than your heat content of reactant, then the reaction is exothermic. Is that easy? So what should be the answer? They said the chemical reaction where the heat content of product is less than that of the reactant. So which is this guy? So the correct option is what? Option B, exothermic. All right, take note of that. Then question 35. Question 35. Which of the following is a fine chemical? Now, one thing that you need to know is this. Chemicals are divided into two parts. We have the heavy chemicals and we have the fine chemicals. Now, when we say heavy chemicals, the main discrepancy between both of them is that heavy chemicals, they are usually of high demand in chemical industries. The while fine chemicals, they are usually not really of high demand. They have low demand. All right, when you talk about demand, making comparison between the heavy and the fine, you should know that the one that has a very high demand is heavy chemical. And another very important thing that you need to know about heavy and fine is that heavy chemicals, they are known by their low molecular weight or mass. Then while fine chemicals are known by their high molecular weight or mass. There's actually one that has a very high value that's under the fine chemicals. It's called, I think, botulinum toxin. That's very, very high. So most times, between heavy and fine chemicals are usually prepared with a degree of purity. So one thing that is considered in the preparation of fine chemicals is purity. Why? Because they often use fine chemicals in drugs production. So purity is of relevance. All right, that's for the fine chemicals rather. Then while the heavy chemicals are those common inorganic substances or materials or compounds that you know. So I can say that under the fine chemicals, let me just give you guys this tip. For fine chemicals, most organic compounds, they are fine chemicals. Most organic compounds are fine chemicals. All right. So they said which of the following is a fine chemical? This is not. Why? Because like this is an inorganic compound. Inorganic. Then paracetamol contains organic compounds. All right, which is a phenolic group. Of course, paracetamol is a drug. And like I said, fine chemicals are often used in drugs production. So D becomes the answer. All right, so take note of that. Then the next question, question 36. A certain gas occupies a volume of 2.0 dm cube at 28 degrees Celsius and 1.5 atm, that's atmosphere. What volume will the gas occupy at 98 degrees Celsius and 1.5 atm? So in this question, we're giving volume, temperature, and pressure. So now looking at this, you can use what's it called, general gas equation for this. That's P1V1 over T1 equal to P2V2 over T2. But no need to stress yourself over that. The reason is because P1V1, that's what so many students will use, over T1 equal to P2V2 over T2. Check. The pressure that was given in the initial and in the final, they are the same. So it means this P1 will strike out the P2. Why? Because they are the same. That's at constant pressure. So it's best to just go with, not to waste your time, go with V1 over T1 equal to what? V2 over T2. Like I said, it's because of the fact that the pressure given in the question are the same. That's the reason why you go with this. So it's best to just go with this to save time. So what was our V1? Our V1 that was given was 2.30 dm cube. Then what was our T1? Our T1 is 28 degrees Celsius. When you convert to Kelvin by adding what? 273 to it. So 273 plus 28. We are to obtain, with the help of our calculator, let's get that. 28 plus 273, that's 301. So 301 Kelvin. Then what about our V2? Our V2 is what we were told to find. What volume? What volume? So V2 is unknown. Then T2, what's our T2? Our T2 is given as 98 degrees Celsius. So we have to add 273. So when we do that, it should become what? 98 plus 273, that should give us 371 Kelvin. So when you now sum up, when you carry out, sorry, when you substitute the values into this, then let's see how we can obtain our answer. What did they say we should find? V2. So by cross multiplication, it becomes V2 equal to what now? Equal to V1 T2, that's this and this, over then the T1, just to save time. So our V1 is given as 2.3. So 2.30 times, what's our T2? Our T2 is 371 over, then what's our T1? Our T1 is given as 301. So with the help of our calculator, let's get that. That should give us 2.30 times 371, then divided by 301. We should get 2.83, 2.83, approximately 2.84. So that is the answer to that question. The next question 37 is still another calculation question. So let's quickly look at that. Question 37. Question 37. Let me just create space here. Question 37, we are given a mixture of gases containing 40 grams of nitrogen, 40 grams of nitrogen, and 112 grams of carbon 2 oxide, that's CO. So we are having nitrogen gas and we are having CO. Then has a total pressure of what? Then the PT, which is total pressure, is giving us 3.6 atm. This question is coming from the Dalton's law of partial pressure. All right. And then they said determine the partial pressure of nitrogen. Partial pressure of nitrogen. How can you get the partial pressure of nitrogen gas? It's simply multiplying the mole fraction of nitrogen gas, then times the PT, which is the total pressure. And for you to obtain the mole fraction of nitrogen gas, firstly, we are given the mass of nitrogen. Mass of nitrogen was given to be 40 grams, and CO, the mass was given to be 112 grams. So we have to get their moles. And how do you go about it? Now you have to divide the 40 by the number of moles. And of course, for you to get that, that should be what? 28. We are given 28. So directly is N2, that's 28. So 28 to get the moles of this. That should give us what? 40 by 28. We should get the moles. of nitrogen. So 40 divided by 28, we should get 1.43 moles. All right. Then what about the CO? CO would now be what? 112. This one is for nitrogen. Then for CO is 112 over, then what did we get? That's for our molecular mass or molar mass of that. That should become 12 plus 16. That's what? 28. So divided by 28. 112 by 28, that should be 4. Divided by 28, that's 4. So 4 moles. So we are having 1.43 moles, and then we are having 4 moles. So we can easily get it. The mole fraction of nitrogen is obtained. Now the mole fraction of nitrogen is obtained by getting the number of moles of nitrogen over the total number of moles of gases, talking about both the nitrogen and the CO gas. So how can you get the total number of moles? It's simply by summing up. So it means that the number of moles of nitrogen is given as, we have gotten it here, which is 1.43, then over, then what's now the number of moles of this of CO is 4, then plus, then what's still the number of mole of nitrogen, because you are summing up everything, 1.43. So when you do that, you have to obtain what now? 1.43 over, then 5.43. Because when you sum up, it gives 5.43. So that's the mole fraction. So we have obtained our mole fraction. So getting your mole fraction is, we can easily get our answer with ease. Now our mole fraction is this. So the mole fraction of nitrogen is this. Then the PT, what's our total pressure? From the question is 3.6 atm. So that becomes what now? Partial pressure of nitrogen is equal to, what's our mole fraction? 1.43 over 5.43, then times what? Times the total pressure, which is 3.6. This will give us our answer. Is that easy? So let's get the answer. With the use of our calculator, then we can get it. That should give us 1.43, then times 3.6, then divided by 5.43. Now, what did we get? 0.94 atm. So that's it. So all you simply just do, this thing is not hard. Just know this formula, that anytime you are told to calculate the partial pressure of a gas, know this formula, that the mole fraction of the gas then multiplied by what? The total pressure of the entire gases. And then for you to obtain mole fraction, you have to get the number of moles of the gas, write it above, and then you sum up all the moles, the number of moles of all the gases beneath, and it gives you something like this. And then you multiply by your total pressure, you get your answer. Is that easy? So the next question is question 38. Question 38. What is in question 38? Let's confirm. Now we are told that, wait, we just now back in. Question 38. 5.6 grams of potassium hydroxide in 250 cm cube solution contains dash. This is very easy. Now, KOH is potassium hydroxide. To get the molar mass of this, potassium is what? 39. 39 plus oxygen is what? 16. Hydrogen is what? 1. When you sum up everything here, you should get what? 56 gram per mole. So if this is our molar mass, remember our chain formula now, mass over molar mass equal to what? CV over 1000 cm cube. Is that easy? The reason why I wrote this formula is because we are giving mass, and then we are giving volume, and then of course molar mass should be there. Then we are told to calculate concentration, because in all the options you are having it in mole per dm cube. So we are looking for C here. What's the mass? Mass was given to be 5.6. Molar mass is what? 56, which is this guy. then concentration is unknown, then volume, what's our volume? 250 times 250 over 1000. 250 can cancel this, 4, and then when you cross multiply, your x should be 4 times 5.6 over 56. That should give us our answer. So with the help of our calculator, we can get that. So 4 times 5.6 divided by 56, 0.4. So our correct option is option D, 0.4. Then 29 or 39. Question 39. What is the question 39? Question 39. The best way to distinguish between Na2CO3, that's sodium carbonate, and NaHCO3 is through reaction with acid, option A, heating, option B, C is hydrolysis, then D is reaction with base. How do you distinguish both of them? Firstly, Na2CO3 and NaHCO3. This is called sodium carbonate, while this is sodium hydrogen carbonate. Now, there is something you need to take note of. All hydrogen carbonates are soluble in water. They are soluble in water and unstable to heat. What does that mean? It means when heated, they get decomposed. Then while this guy is soluble in water but stable to heat. So it means you can use heating action to distinguish this from this. How? When you heat this guy, this Na2CO3, when you heat it, apply heat on this guy. Now, no reaction will take place. But if you apply heat on this guy, NaHCO3, when you heat this guy, you are going to obtain Na2CO3 plus H2O plus CO2. So it means this can decompose when heat is applied, but this one remains unchanged, meaning that there will be no reaction. So you can use heating to distinguishing this from this. All right. So that's it. Then question 40, the last question. Complete oxidation of propanol will yield dash. Of course, propanol is an example of a primary alkanol. And remember that partial oxidation of primary alkanols yields what? Alkanal. So since this is primary, it gives propanal. All right, that's for partial oxidation. Then complete oxidation will give what? Alkanoic acid. That's for the primary alkanol. So hence this should give propanoic acid. It's very easy. So the correct option is option C, propanoic acid, meaning that any primary alkanol, when oxidized partially, you get alkanal. Then when oxidized completely, you get alkanoic acid. Like butanol, partial oxidation butanal, complete oxidation butanoic acid. I've done a video lesson on alkanols. You can check the channel for you to update yourself. So it's with my hope that you have understood everything that I've explained with regards to these 40 questions, possible questions that you can see in your forthcoming Jamb 2025 examination. Do well to watch this video over and over and over again until you master it. All right. So if you are yet to subscribe to this channel, do well to subscribe, and also invite your friends if they are yet to subscribe, and give this video a like button if you love the video. And I wish you guys all the best. Make sure you prepare adequately for this exam, because I know that you are coming out with flying colors. Thanks again for watching, and remain blessed.